more than one parameter that need to be jointly monitored. Okay, for example, we have internal diameter and outer diameter for a bearing. These are related parameters that need to be jointly monitored. It's not will be misleading if we just independently monitor internal diameter and outer diameter, because these two parameters are related in order to make a bearing is functioning. Okay, we also have seen that in many cases, for example, for assembly operation, you have two holes, okay, that need to be assembled to go into another components. Okay, they need also to be jointly monitored. So one way to solve this problem of having more than one parameter that are correlated, we use a multivariate SPC. Yeah? So I've explained this that when we have two parameters, if we monitor independently and they are not correlated, that will be fine when we have a box as a region for monitoring. Okay, we have a box here. But when these parameters, two parameters are correlated, okay, the box as a control boundary is not enough. Okay, it's not enough. We have to look into correlation, okay, between these. So normally we have seen that in correlation we have scatter diagram. So this is doing the scatter diagram to see whether it is positively correlated or negatively correlated or positively correlated. So when the parameters are independent, it's still okay to monitor using what we call it is a circle here. Okay, a circle as a control region. But when it is correlated, it's going to form as ellipse. Okay, ellipse as a control region. So this is very difficult if we look at like this. We use this traditional method of monitoring because we do not know exactly which point is in sequence. Okay, it's not in sequence now because when we're plotting 2 points, I mean we plot a joint parameter to 1 point on the x1 and x2 region here. We lost in terms of sequence. We do not know how it looks like in the sequence. So the scholars have come up with a better method, which is they call it chi-square chart. Okay, in this case, example of chi-square for p equal to 2, meaning that you have two parameters. Okay, parameter 1 may be internal diameter, parameter 2 may be outer diameter. So they can jointly monitor these two parameters using chi-square chart. Okay, so this is where we get the statistic for chi-square. Okay, the formula looks scary, but actually when we implement it, it's not really difficult. But we will look later on the example on this. Okay, so this is what we monitor, the statistic of chi-square. This chi-square actually can be, will be almost equal to hoteling T2 when the n size are getting big. Okay, so that's why we see that there is T-square control chart. Okay, so when the size of n get bigger, so the chi-square will be approximately the same as T-square control chart. So this is representation in terms of matrix. Okay, we have matrix here. So we call it hoteling T2 control chart. Okay, to handle when you have multivariate parameters that need to be jointly monitored. So you can monitor 2 parameter, 3 parameter, 4 parameter, and so on. But here we just limit our discussion to 2 parameters. And the control limits are divided into 2 phases. We have, remember, in control charting procedure, we have phase 1 and we have phase 2. Okay, in any control charting procedure, we have phase 1, phase 2. Phase 1 is basically at the beginning of preparation of control charting where process is not stable. Okay, we need to revise the control limit. Okay, we need to discard the point which is outside control limit, need to revise until the process is stable. when the process is stable, okay, we call it phase 2. So we use this control limit control chart that is produced by phase 2 for monitoring the future process. So you see the difference here is only very minor difference. Only this is positive, this is negative. Okay, in the case of T2 control chart. Okay, for phase 1 and phase 2, it is almost the same, only the minus and become plus here. And this is F distribution, okay, F distribution. So this is where we decide the control limits. Okay, what we monitor is this value. Okay, this is what we call it. The statistics that we monitor is the chi-square. Okay, or when the n is big, this can be, okay, approximated as t square. Okay, t square. Right. Yeah, I think just look at this example. Okay, t square control chart. This is where tensile strength and diameter are two important quality characteristics that are to be jointly controlled. Okay, we jointly control the tensile strength and the diameter. Maybe you have something that you would like to monitor. Okay, the diameter is important, and also the tensile of this also important. Okay, you want to see these are, you cannot monitor only the diameter or tensile, but it has to be jointly monitored. So the quality engineer has decided to use n equal to 10. So what he has, he take 10 samples. Every time he take 10 samples. Okay, 10 specimen each sample. Okay, so he every time he take 10 and each sample. So he has taken 20 preliminary sample. So it means that he has, okay, 1, 2, 3 until 20. Okay, 27 samples. Okay, so the n, okay, the n is 10. So it means that for number 1, okay, if I put it like this, so he has, it has, okay, if we put it in terms of variable, so this will be x11, x12, okay, until you have x1, 10. Okay, so every sample he take 10. Okay, n equal to 10. So we go to another subgroup. Okay, in this example, they said it 20 plenary samples. Okay, so meaning that subgroup lah. Okay, so you got another 10 until 20. Yeah. So you are taking 10 for each subgroup. Okay, on the basis of this data, he conclude that x double bar is, this is the grand average. So he take the overall for the tensile and also for the diameter. Okay, so x1 is the tensile. So x2 is the diameter. Okay, so having this data, okay, maybe I can show this for you to get better idea. So we have this 20, right? This is 20, and we take, okay, 20 here. Sorry, n equal to 10, right? N equal to 10. So every time you take 10. So the tensile strength for the subgroup 1 is the average. This is already the average. Average 115, and diameter is the average diameter from the 10 sample. Okay, so let's say this is sample K We got K there, K number 1, K number 2, until K20. And he have n equal to 10. So he has 1, 2, until the 10. Okay, so he has 10 there. So now he take this. Okay, so he has one is the strength, tensile strength, the other one is diameter. So he has x bar, 1 here, x2 here. Okay, which is taking the measurement. Okay, of course you need to have, okay, if you are taking here is diameter, here is the strength. Okay, here is the strength. So if here is x1 measurement, x1. So he take all this 10 and get this value. Okay, of course he need to have another set of data which is for x2. Okay, so maybe okay, I don't have space here. Maybe I just, again I put it another way to get it clearly for you to see. So what he has is, let's say this is K. Okay, this is K. Okay, K1, K2 until K20, yeah, 20 subgroup. So x1 is the tensile, x2 is the diameter. Okay, so he has here 10 values. So I just represent just a symbol here. Let's say the values of strength, you have 1, you have 2, until you have 10. 10 measurement. Okay, 10 measurement. So every time he take 10. Okay, so now you got x bar here for 1. Okay, adding all this number, divide by 10, you get this, the value here. Okay, which is what he has it here, 115.25. Okay, he didn't show all this detail of the 10, but he already summarized it in terms of x bar. Okay, x bar 1, x bar 2, x bar 1, 2, okay, x bar 1, 3, and so on. So this is the value that he has here. Okay, until the 20th. Okay. Okay, this also got 10 values, but it's not shown in the table. Not shown in the original table. So this is 20. So this value is actually the value that is given here, which is the average of the 10 value. So this is for this column. So the second column here is diameter, which is x2. Okay, x2. Okay, the x2. Okay, x2 is coming from another set of measurement of diameter. This is diameter. Okay, he measure 10 unit. Okay, 10 unit here, and get the average here, and he got this value 1.04. This is what he got it. Okay, transfer to here. Okay, so what you see on this table is already summarized value in terms of averages of tensile and diameter. Okay, so he got this value until you have it. So I hope that is clear, right, on this one. Okay, so this value It's already the averages of each of these 10 measurements. Okay, for this one and for this measurement. Okay, so because you have n equal to 10, you are able to measure the variance. Okay, S2 is the variance. This is the variance of tensile. This is variance for diameter. This is covariance. This is covariance. So variance is square here. The standard deviation square is the variance. For tensile, this is the variance for diameter, and this is covariance. Okay, covariance for tensile and diameter. So this is what you got it here. Okay, so finally in this table we can get the grand average. Okay, the grand average is given here by summing up of all this value. You get the grand average for tensile, the grand average for diameter, and also we can get the average for variance of tensile, average for variance for diameter, and also average for covariance. Okay, coming from here. So that I put it here is this formula to get it, the variance. The variance. So it is 1 over n or minus 1, which is n is 10. Okay, summation of the differences between individual value minus the average for that parameter. If you are now is tensile, the average for this tensile for that particular group lah. Okay, what is the average of that? So this is where you get this value. This value. I think this representation is as J here. J is referring to this sample. The notation is not the same here. So Xij is referring to this individual value lah, like this one X11, X12. Okay, so don't get confused with that, because the notation is not consistent here. Okay, so basically what it says that summation of deviate from the mean of each of these. Okay, each of these. So you get 11525. So that is the value of here, value of X bar here. Okay, so and to get the covariance, this is the formula for that. So this is what is entered into this column. Okay, so having this now, actually in this example, it is given to us. Okay, the data already calculated for us here. So we have the grand average. We have for grand average for tensile, grand average for diameter, and also we have the variance for tensile, variance for diameter, and also covariance. So now we have to set up T-square control chart. Okay, T-square control chart. So this is the data, and now okay, what need to be done is okay, we can use this formula to find the T value. As I say that the T value, okay, this statement is important. For large n, T square is approximately chi-square distributed with P degree of freedom. P is, in our case, P equal to 2 because we have two variables. Okay, so this one can be approximate as T square. Okay, so the formula looks scary, but actually not that difficult because we already have this data. So this is the variance for tensile. This is the variance for diameter. Okay, minus covariance square. Okay, square of this. Sorry, this is square. Yeah, this is covariance. Okay, square for tensile and diameter, and on the top of that is n. N is, our case is 10. Okay, so this value already given, n is equal to 10. So the variance for tensile is 1.23. So it's given here 1.23. Okay, 1.23. 1.23. Okay. Also, we can get it from here. Okay, 1.1, which is the averages of this. The average of that. And the second, which is the variance for diameter, is given. Or we can, I mean, it was calculated lah from the original data. So it is 0.83. Okay. 0.83. Okay, you see the formula here, minus. Okay, this is the covariance. Okay, the covariance is, you can get it from here. The covariance. Okay, so the covariance is okay, can be obtained from here. Okay, so this is the covariance. The formula for covariance is this one, for the individual one, for the individual one. It is, we get it, it's individual value. Okay, 1 over, in our case is 10 minus 1, which is 9. So it will be the summation of X is the raw data. Okay, the individual data that we have. For example, we have data here, 10 data, right? Okay, we have 10 data. So each of these we got the average. Okay, the average value, which is coming to here, the average. Okay, the average. Oops, sorry. The averages of these, okay, the averages of these will come to here. Okay, and the second one, we have another averages of these will come to here. Okay, so the individual value that we have inside this for 10, okay, this value will be minus the average. This value minus with the average. The third value minus the average. Okay, this is this part. Okay, and the second part is the individual value minus the average of this diameter. Okay, remember that we have x1, this is x1, this is x2. So if you do it once and you put in Excel, you can get this deviation. After that, we get it, the summation of this. Okay, do it individually, in for subgroup 1, subgroup 2, subgroup 3, until subgroup 20. This is where you got the summation here. Okay, so you get this. In our case here, is going to be 20 lah. Okay, so don't get confused, because this value formula here is from the books here, so meaning that summation of 20 lah in our case. Okay, because we have 20 here. Okay, which is I equal to 1. Okay, okay, so in this case, you are taking the covariance. Sorry, you are taking the variance. The variance of this. So in this case, n going to be 10. Okay, remember this is 10 on this side. 10. Okay, we are taking okay. This is where you get this value. Okay, so in this case, this the variance here is actually the n was 10. Okay, because we have this 10. We have this 10 unit. Okay, every time we have 10 units for each subgroup in order to get this value. Okay, so this is why I put it 10 here. Okay, so when you are calculating, okay, I think there is a big confusion here because we have subgroup and this one, okay, this formula is to get this value. Okay, and again, okay, I did a mistake just now. So actually the n here also 10. Okay, not 20, sorry, it's 10. Because why? We are calculating the covariance between the x1 and x2, which is each of these x1, x2 comprise 10. Okay, here is 10. Okay, also here also you got 10. Okay, the pairing of these are 10 and 10. Okay, so this is where you get it. Okay, it has nothing to do with the 20. Yeah. So is it clear how to get these values? Okay, please respond to chat box or you can on your mic. Okay, right. Thank you, Zaid. Okay, so the n here is 10. Sorry, I was confused before this. I said 20. It's not 20. It is 10. Okay, for this formula and this formula also. Okay, so in this example already simplified for us. It's already given the variance and also covariance. So now the t square. Okay, the t square. How we get the t square values? This square values is coming from this formula. Okay, this is where you get the t square value. Okay, the t square value. Okay, so this is approximate from chi-square. Approximate from chi-square. So the general formula, because the individual value is different, so in this example here, the t square, okay, t square, which is using this formula, we just replace the values for variance, for tensile, variance for diameter, minus the covariance. But remember, this covariance you have to square. Okay, you have to square this covariance. You see here, it is very easy to make a mistake because here is covariance. In the formula is already square here. Okay, this also covariance. The covariance is the square of standard deviation. But this one is sorry. This is the variance. Okay, the variance. This is also the variance. So this data put here is already squared values. But when you have covariance, okay, covariance is given by this. Okay, the covariance is okay. So we need to square this value. This is what you get it here. Okay, in the formula it looks the same, looks the same, but actually this is has to be squared. This data already squared from beginning. Okay, but this data you need to square at the end. Okay, so if you look at the table, this table, you look at this table. Okay, if I may erase this one. Okay, you see here, this already squared. This value is already squared value. This also squared. But this one is single. Okay, these values cannot square yet. So whatever you got from the calculation need to be squared when you enter in the formula. Okay, this value is not squared. Okay, so we have to be careful in using this formula. So 0.79 is squared. Okay, 0.79. So where do we get 0.79? This is showing the sample of calculation. 0.79. Okay, 1.25. I'm not sure where they got this number. 383. 383. which particular sample they use here. Okay, the statistic will be used. Okay, so you have.
Yang bawah sekali, Doktor.
Oh, yeah, sorry. Yeah, in bawah sekali, yes, yes. All right, this one. So they are taking the averages. Okay. So, but in the formula, it doesn't show that. Okay. Yes. So ini yang bawah sekali. Okay. The last, the overall lah, the overall. Okay, the overall values. So you have 1.23. Okay, from here. So this is what you get it from here. Okay. So 1.3. Okay, not only this, we also have the whole. So now we are focusing on this. 823, 83, and 0.79. Okay, so this value is the overall, from the overall data that we collected. Okay, and then you got have here is 10, and then this one is the same value, 0.83, and this one. Okay, so we summarize it now in terms of x bar 1, because this value will change. The other value will fix. X bar 1, x bar 2 will be coming from here. Will be coming from here. Okay, you have this. I think if you put in Excel, you do once and then the rest just copy the formula. So this is x1, this is x2. So the value change, the change as it goes until 20. So in the general formula here, okay, you make it a variable. Okay, so the variable here will be depending on the subgroup. Okay, x1, x bar 1, x bar 2. Okay, you have until 20 kan? Okay, x11, x12, x120, here x21. So for each of, because this is what actually we plot. Okay, what we plot. So this value will become x21, until you get x bar 20. Sorry, this is 2. Okay, very easy to get confused. This is actually is variable 2. Okay, variable 2. Okay, subgroup 1. Okay, so you can have also for until this value will keep changing until you have 20, meaning that the diameter lah, I mean this is the diameter, until the number of 20. Okay, I can erase this part to make it clearer. Okay, so what it shows here, this is for diameter, the average for diameter. This one is tensile. Okay, so this value also will keep changing from x bar 1 until you have x bar 20. And 20. Okay, so the individual value that we calculate here, okay, the individual value that we calculate here, the whole thing now will contribute to only 1 point every time we change the x1 and x2. Okay, so the second point, okay, when you change this value and this value. The third value is when you change this value and this value. Okay, so that's where we plot the statistics of t squared. But now the question is how can we decide? How can we decide the control limit? Okay, we have control limit in T-square chart. The important control limit is only upper control limit. Lower control limit is not important. Okay, the control limit is decided by this one. Okay, upper control limit is, we have this formula. Okay, remember that I said phase 1 and phase 2. So phase 1 and phase 2. So in this case is okay, we start with phase 1. The control limit, the control limit. Okay, the control limit, the phase 1 control limit, it got negative here. The phase 2, when the process is stable, you remove assignable causes, eliminate the root cause of the instability. We revise the control limit, but the method of using is this from negative become positive. The rest are the same. Okay, this one we have to see from table, in the F table. So in this example, okay, it shows here that we have, this is from phase 1. Okay, from phase 1, you get 13.72. This is what you plot here, 13.72. Okay, this is what is plotted here. Okay, if I erase this, so meaning that any T-square value below this line is showing that the process is stable. Okay, the process has no problem, both the tensile and also diameter. Okay, so the challenge, another challenge that we face is if one point is outside. Let's say one point is outside. Do we know who caused? Let's say one point here outside. Okay, let's say okay, this process is continue. It is continuing, and suddenly you have a point outside here. Okay, so the process is having problem. Okay, so the challenge here is who caused this problem? Is it causing by X1 or is it causing by X2? Okay, who caused the problem? This is a challenge. So actually this is very deep into the problem of monitoring. When we monitor more than one, we jointly monitor, but now we want to know who caused the problem. Is it because of diameter or is it because of tensile? Okay, so this is create another problem. So this problem is actually there are some different opinions by the scholars. There are people suggesting try to separate, okay, to know that which are the culprit in this out of control points. So they suggest to separate using D. Okay, this example is given by Rangas and Montgomery. These are expert in this area, and they suggest that using to decompose the value of T by using this method. So I think it's too detailed for us, and if you need to know this, you can go and see the e-books, page 520 onwards. Okay, maybe later on, if you are facing the problem of joint monitoring, you want to know who caused the problem, okay, you can go and refer to this reference, okay, how to separate and to know exactly who is actually the culprit. Is it X1 or X2? All right, any question? Yes.
For the P, is it always 2?
In our example, P is equal to 2. Okay? But if you have 3, if you have, let's say you have internal diameter, you have outer diameter, at the same time you have thickness, so P will be 3. Okay, P is depending how many parameters that you jointly monitor. I think having 2 is already complicated, but if you have 3, it becomes more complicated. But there is a method to solve it. Okay, a method is a similar method, but you have additional variable. You will have X1, X2, X3. X1 will be tensile. X2 will be diameter. X3 will be, for example, thickness. Okay, so more complex lah. So I think if you can understand up to P equal to 2, I think the overall understanding is there as a baseline understanding lah for multivariate process monitoring. So, okay, any more question?
Doktor,
Yeah.
untuk yang previous example, mu1, mu2 tu apa?
Okay, mu1, mu2 is actually being estimated, okay, from the process, stable process. Okay, mu, oh, you mean here, is it? This one, is it?
Ya, Doktor.
Okay, this is actually the grand average. Okay, for diameter, in the example earlier is for diameter. Okay, thank you for asking. I overlooked this. This one is for, okay, this one is for tensile. Sorry, it's for tensile. Okay, this one is for diameter. Okay, so x2. So we use mu here to show that it is coming from population lah. Okay, coming from. So actually it's estimated value from x double bar. Okay, this also estimated. Okay, so estimated. Okay, so when we use population, we use mu. Okay, but it is estimated from sample here lah. Okay, estimate from sample. Is it okay? If you see here, this is what we get. So this is mu, right? Mu1. So this is mu2. Okay, mu2. So where you get this value? 115. You see 115. 115 is here. This value. Okay. 1.06 is mu2. Okay, which is x double bar. So we approximate the population based on the sample. Okay, this symbol mu is normally used for population. Is it okay?
Okay, Doktor.
Right. Okay, so there are other methods that has been introduced by scholars. So they say especially for monitoring small correlated parameters, we can use multivariate UMA. Before this, we see UMA only for one parameter, okay, for one variables. But we can also use this to replace as, instead of using t-square, we can use multivariate UMA. So I do not intend to go in detail on that, just to introduce to you, there are other methods. Okay, UMA, univariate, UMA can be also multivariate. Okay, so we call it multivariate UMA or multivariate QsW. Okay, so jadi kalau kita kata UMA jadi mu apa ni, mioma lah jadi. Okay, so still using, looks familiar, this one, we have lambda here, 1 minus lambda, and then we can plot this, okay, using this isometrics, and the covariance is calculated by this. Okay, so I think just aware of that. So I would like you to solve this problem, okay, using the method that we have discussed for t-square chart. Okay, so it's given here. This is the mean in terms of matrix here. This is mean for x bar, which is you have x1 here. So this basically this is x1. Okay, so this is the mean for x2. So this is where you get it, supposed to get it here lah. This value ni. So actually this value is going to be 55 here, and this is 30. Okay, the grand average. And this is covariance matrix. Okay, covariance matrix. So it's given here, covariance matrix. So I think that's all for this multivariate. Okay, we have just a few more minutes. Okay, let me quickly introduce to you on attribute control chart. Okay, actually that was my intention to cover for today. The attribute control chart, which is much simpler than what we have learned in variable control chart. So far we have discussed variable control chart. Okay, so for variable, where the inspection is done by a method of, for example, using go no go, okay, or using by inspection. Okay, this will be easier, much easier than what we have learned in variable control chart. Variable control chart where measurement data is given in terms of numbers. Okay, given in terms of numbers, you got a tensile, you got a thickness, you get diameters and so on. Okay, but in the topics of attribute control chart, we just concerned about whether it's pass or fail. Okay, like you are doing some of your courses like LI, industrial training, pass or fail. That's all. There is no grade. There is no A or B or C. So this is like attribute. Okay, attribute control chart. So yeah, I would like you to introduce this so that you can have a look in your where is okay, having so many files open, sometimes confusing. Huh? All right, so this is in chapter 7. We go back to chapter 7. Okay, chapter 7. So I skip it earlier because we need more time to discuss variable, but this one is becoming simpler, okay, easier, because the data itself also not in terms of measured like we have the numerical values, but here is just counting. Okay, we just count how many. So what we call here is attribute control chart. Okay, attribute control chart. Okay, so in attribute control chart we have chart, for example, fraction control chart. Okay, fraction control chart. We have we have P chart, or we call it fraction, or proportional control chart. Okay, we have NP chart. Okay, we call it C chart. Okay, C chart. We have U chart. And we have demerit chart. So these are the chart that I will discuss inshallah by next week. We're going to focus on variable control chart. Okay, please read this chapter 7. Chapter 7 on attribute control chart. Okay, covering this. Okay. Okay, so under the category of attribute control chart. So the chart that you have seen so far up to this point is variable control chart. Okay, there are so many types of variable control chart. We also have many, at least 5 we will cover in this class. Okay, for attribute control chart. Okay, so it is simpler. You see the formula also simple. Okay, this is a formula for P chart. Okay, whether it's standard data or no standard data, we have formula for NP chart. Okay, NP chart. Okay, this is NP chart. Okay, the formula is very simple. And we have chart for C chart. I think it's not in this order, but anyway, there are demerit chart. Okay, also yes, C chart is here. Okay, very simple. C chart. So okay, this again C chart, and we have U chart. Okay, also very simple. If you can understand variable, the attribute will be simple. Okay, very simple. And we also have okay, these are demerit. Okay, demerit is a bit confusing, but if you understand the other like U chart and C chart, so this demerit system, okay, should be easy then. Okay, we classify the defects into different categories: serious, or very serious, minor. Some textbook they use it like critical, major, and minor. So we can classify that in terms of demerit control chart. Okay, so I think that's all for today. So any question before we end the class? I already shared with you in the Telegram this slide for multivariate. Please do the assignment that I've given at the last slide on the multivariate. Okay, any question before we end the class?
No, Doctor.
If there is no, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.